Chapter 2 is all about data and presenting information. So thinking about the sources of information internally and externally to the organisation, and also thinking about how we can collect information via different sampling techniques. Also thinking about presenting that information through reports and through tables and charts, interpreting it, and finally thinking about using spreadsheets within management accounting. Data and presenting information then is a chapter which looks at, first of all, where we can obtain information from. So we're going to be looking at primary data and secondary data, the differences between information which is collected specifically for the company's purposes and information which it collects from other sources. We'll also be looking at what information is available internally compared to externally and the sources and reliability of those data groups. When we're collecting data then, rather than doing a census of the entire population, we might decide to look at a sample, and we will introduce and define the 4 types of random samples: systematic, stratified, multi-stage and the truly random samples, as well as non-random samples, so looking at quotas and cluster groups. Once the information has been collected, we then need to think about how we can present that information and interpret it. So we're going to be looking at presenting information through different types of tables and charts. So we'll be looking at bar charts, pie charts and scatter graphs. We'll also be looking at report formats. In addition to this, whilst we're thinking about collecting the information, we need to think about what impact the economic environment has on costs and revenues at a low level. The final area of this chapter then is looking at spreadsheets. Within many businesses, spreadsheets are widely used, and you will be required to work out some basic Excel formulae for your exam. As businesses are going to be using information and data to help them make decisions, we need to think about the different types of data that are available to us. So there are different types then that we need to consider, and the main distinction is between primary data and secondary data. So primary data then is information which is collected for a particular purpose. For example, if you wanted to know what Christmas presents people wanted, you could go and ask members of your family, and that would be primary data. Secondary data then has already been collected by somebody else for some other purpose, and so that might be reading a magazine article, for example, about the most popular gifts. That would be more people's data collated. More terminology then with discrete data. Discrete data then only has a finite number of values. So, for example, with your month of birth, there are only 12 possible answers that could be given regardless of the size of the population. Continuous data then can take on any particular value, and it's something that's measured rather than counted. So, for example, your weight. Sample data then is when we look at a sample of the population or a selection of individuals rather than the population as a whole, which is called population data. Here then we're looking at understanding the key advantages and disadvantages of using primary data, so data that we are collecting for ourselves. The main advantage then of primary data is that it's tailor-made. So you're making all of the decisions, and you can make the decisions then about what information to collect, so which questions to ask, and you can ensure that it's specific to your requirements. It also means then that you're going to know the source, because you've decided who to approach for the information, and you also are aware of the collection method, And that in itself means that you're aware of any limitations. So you know, if you're collecting your own information, if there are any potential pitfalls in it. Collecting primary data as well should also mean that it's up-to-date information if you're going to be collecting it now. The disadvantages, though, of primary data are primarily the cost. So it's very expensive then to set up a survey and collect all of the responses and analyse them. And it's also very time consuming to approach all of the people in your sample or in your population. We also need to think about where the information is going to come from. It could come from either internal sources within the organisation or external sources. Information internally then is very wide-ranging. It's anything that is available to the organisation. They're going to have access to all of their different records. So that might be the financial accounting records, or it might be information to do with HR from payroll or timesheets, from the production line, or it might also come from historical data, especially if we're wanting to be looking at trends. External data then, there's a wide range of external information, and businesses need to make the best use of that. So it could be asking people, so some primary data such as market research, interviews or other forms of questionnaire, or it might come from information that's been published by the government, so different types of statistics and indices that we'll be working out how to calculate later on, or it might come from other external bodies like banks, trade associations or newspapers. There's a wealth of different information as well for things like the internet, the library. For your exam, you need to have a general awareness then of how the wider economic environment impacts on both the costs and revenues of a business. What follows then is a worked example where we're looking at an accountancy training business and thinking about how it could be affected by a recession. So the sorts of things then that are happening in the environment as a whole, and then the impact that these are having on the business. So recession then leading to a decline in GDP, gross domestic product, means that there's less money in the economy and therefore less discretionary expenditure, which would result in a fall in the demand for courses, because accountancy training is not a necessity. If the firm operates then in a city which has got lots of financial services firms and is bucking the change overall, it might be that this is going to reduce the fall in demand that it's expected. As well then, in this recession we might see increased inflation, so higher prices mean that the students purchasing the courses will have less disposable income, and so they're going to have less money available to spend on courses. In addition then, it's going to see an increase in the staff and the facility costs through that inflation. In a recession as well, low interest rates are a common factor. They have an advantage to the business because it should mean that the business will be able to raise debt finance cheaper to fund any expansion of the business. Students also mean that will benefit from the low interest rates because they might have lower living costs through mortgage repayments, which can help combat price inflation and maintain their disposable income. Or alternatively, it's going to make it cheaper for them to borrow the funds for the course fees. If tax rates go up, then that will reduce the after-tax profit made by the business. So that reduces the return to investors through dividends, or if that's to be reinvested in the business, that limits the source of retained earnings. In a recession as well, governments might look to cut back on their spending, and that might mean that any contracts with the government agencies could be at risk. So students then that are coming from government agencies could be reduced. How this would be tested in F2 or FMA is going to be via multiple choice questions. So the information in this table is as complicated as any information on this will get.
Section 4 covers big data. To meet the syllabus learning outcome, you need to be able to describe the main uses of big data and analytics for organisation. But let's think by distinguishing what we mean by big data. Big data refers to the mass of data that society creates, and it goes way beyond the normal data that we used to use for accounting purposes. So sources of big data can include social networking sites such as Facebook and Instagram, maybe internet search engines, mobile devices, and any trackers on things like cars or aeroplanes, even down to information that we can gather from our fridge if our fridge has data tracking technology that helps us recognise when we need to reorder specific food items. So basically, big data covers a huge mass of data that is created throughout our world. The main characteristics of big data are described through what we call the 3 V's. So the 3 V's are volume, velocity, and variety. When we look at volume, big data is characterised by a huge volume of data. So the scale of information, as we said, now extends way beyond what we used to use for accounting purposes, and we can gather data, as we mentioned, from cars, even video games, or refrigerators. Our mobile phones gather lots of data, so I don't know if you've maybe ever been texting your friends or been in a WhatsApp group where you're discussing something, and then the next time you log on to your social networking sites, you start to see adverts for the things that you've been discussing through your WhatsApp group. So lots of information can be pulled from our mobile devices. The velocity is in relation to the speed. And again, a characteristic of big data is data that we can get access to very quickly. So it's real-time data. It's data that's available immediately. And then finally, the variety. It comes in both structured and unstructured forms. So there's lots of different data that we can now use within a business to help us make decisions. And that takes us nicely onto the uses of big data. So the main use is to be relevant for decision making. And to be relevant for decision making, it's important that we can pull between useful data and unuseful data. Useful data that will help us with decision making is things like whether the company should maybe enter into a new market or whether it should launch a new product. So we might be able to gather information from consumer preferences by looking at social networking sites to identify whether we think that there will be a good enough demand for a new product before it's launched. It's important that we analyse all the relevant information, as we mentioned, to make sure that we remove any irrelevant data so that we can generate a predictive model of what the outcome could be based on the data that's relevant. If we think about big data and how it adds value to the business, it will add value to the business by increasing profit, enhancing shareholder value via growth in the share price, or enhancing brand value if we launch a new successful product, or the intellectual value of the people who work for our company. So it can be used to analyse lots of different opportunities that can create value for the business. Here we're given a very simple example that a holiday company could analyse data trends for identifying the areas that tourists prefer to visit at a specific time of the year, and then it could use that trend to make sure that it makes a relevant decision to improve the range of holiday locations that it offers at specific times of the year. That could boost revenue for the company, which could lead to an increase in shareholder value via growth in the share price. If we think about big data and the customer, obviously understanding your customer's needs is fundamental. So we could use big data. We can use, again, information from maybe social media sites to make sure that we understand our customers' requirements. That will enable the company to respond very quickly to customer needs. So again, remember that we said the velocity of this data is that it's available real time. So instead of using historical information, we're using real-time, up-to-date information on what the customer wants, and we can use that to add value to the customer experience and improve customer loyalty. Big data must also be aligned to your corporate strategy. So for example, if your corporate strategy is that you want to expand into new markets, you could use that big data to understand those markets, make sure that you make improved decisions that will add to business value. Finally, if we think about the effect of big data on decision making, big data has a huge positive impact on decision making because those decisions can now be made very quickly. The information is available real time. It enables the business to respond earlier than it would have done using historical information. The decisions will be based on current needs, current wants of your customers, rather than, as we said, historical information. So we can take the current situation again from the data available on social media sites or search engines. That data can be quantified, so we can look at the number of hits on a specific site or the number of likes for a specific new product that we're maybe considering launching. And we can bring all of that information together to make sure that value-adding decisions are made by the business. Finally, using big data will enable companies to think outside the box because we're now starting to consider all factors that are up to date in real time and not just the ones that the managers would have historically thought of using historical business plans. As we mentioned, the syllabus learning outcome, to meet that, you need to be able to describe the main uses of big data and analytics for an organisation, and its most valuable use is to make good, up-to-date, efficient decisions where the company can respond quickly to customer demands and needs.
Collecting information about the entire population is very onerous because it's very time-consuming and expensive. As a result, then, we might decide to use a sample rather than the population as a whole. From a terminology point of view, if the entire population is examined, then that would be called a census. In the United Kingdom, a census is carried out every 10 years to try and capture and provide a snapshot of the population as a whole for planning and forecasting. This is undertaken by the government, but it's very expensive and very time consuming. So for the majority of decisions, a sample will be collected. For the sample to be useful though, we need to make sure that it covers all areas of the population and it isn't biased towards any particular viewpoints or group of the population. As a result, we need to make sure that we understand the different techniques that could be used for selecting a sample and understand the advantages and disadvantages of using those techniques. The first one then is random sampling, and everything and everyone in the population has an equal chance of being included, so this should ensure that it is free from bias. And it can be done using random numbers, which might come from a computer program or a book of random numbers, and that's what enables the sample items to be selected. If you use random sampling, then there's a full range of variations inherent in the population. And you could end up with a sample that is unrepresentative. So just because of the way, the randomness, if you like, of the selection might mean that you end up with, say, more boys than girls being selected than are present in the population as a whole. You could also end up with the sample being scattered over a very large geographical area, which might make it difficult to actually go and collect the data. We might not have a sampling frame that's adequate for our needs for understanding the population, and numbering all items of the population can be very time consuming and laborious, so that you can then apply those random numbers. It's also expensive to do because you have to go through this process of numbering the population and selecting people at random. As an alternative then, we can have some quasi-random sampling, which are a form of random sampling with slightly different characteristics. And we're going to consider systematic, stratified and multi-stage sampling to overcome some of those drawbacks of random sampling that we've just talked about. A systematic sample then is a good approximation to random sampling. So rather than using random numbers, every nth item will be selected after a random start, and the gap between each item will be known as the sampling interval. So if you've got 1,000 people to sample and you wanted a 1% sample, then you might go for every 10th person in the population. It's much easier to select the sample items, and it is reasonably random, providing that there's no pattern to the distribution of items. So, for example, it wouldn't work as well if there was a pattern that every 10th person was perhaps the highest earner or the oldest. To use systematic sampling, though, you need some kind of sampling frame, and you also need access to the entire population. If there is a regular pattern, then you will end up with some bias in the sample, and it still can be expensive to select every nth item and actually go ahead and sample it. With stratified sampling, the population is classified into groups which are known as strata, and a random sample is taken from each group proportional to the size. What that means then is that the final sample will be representative because all of the important groups, the strata, will be represented in the final sample. It also means then that those samples should be in the same proportions as they exist in the population as whole, and every stratum is represented by a randomly chosen sample, so we end up with an increasingly precise and accurate sample. The problem is we need to know information before we can start the sample about each item. So we need to know what strata to put them into, and it's time consuming to actually make those divisions into the strata. The next type of sample that we can consider then is the multi-stage sample. So what we do is we divide the population into groups, and a small group of these is selected at random, and then these groups are subdivided again and again, and you can repeat the process as many times as you want. It approximates to a random sample, but doesn't require a large sampling frame because immediately you're reducing the number of items. So it suits large populations, especially those which are geographically diverse, and is much cheaper because you can collect the samples quickly. It isn't truly random though, and it might be biased if only a small number of regions are selected. So for a multi-stage sample of the UK to work, you might decide first of all to split into counties, and then to divide counties further, and perhaps into districts, and then you might divide those districts into perhaps electoral wards, and then sample a small area within those. It will work well if you have a good coverage and don't have too few regions selected. Random sampling then is all well and good if we have a sampling frame. However, if we don't have a sampling frame or we cannot establish one, then we have to think about a non-random method of sampling. And the two that we're going to consider are quota sampling and cluster sampling. Quota sampling then is when market researchers are going to stratify the population and restrict the sample to a fixed number, so sort of first come, first served. So if they wanted to obtain information or opinions and they needed 40% females and 60% males, they wanted to survey 100 people, they would just ask the first 40 men and the first 60 women. This means that it's fairly cheap and quite easy to administer. You can have a large sample if you need to, because you can just extend the number, and you don't need a sampling frame. And in some particular cases, it might be your only approach. And if you're collecting opinions where you haven't strated the population or you can't, then actually it could be fairly accurate. The problem is that bias might exist. So first come, first served might attract keenest members of the population or a particular type of customer. So those people that are at the shops early in the morning might be different to those who come later in the day. It's not satisfactory if you need results that are theoretically and mathematically valued, and we have no idea of the value of any sampling error. A cluster sample then is where we're going to select a subsection of the population that's deemed to be representative of the entire population. So again, we don't need a sampling frame, and it's a good alternative to multi-stage sampling, but has the advantages of being cheaper and quicker to administer. But like so many of these techniques, there's a potential for bias, and here it's quite considerable. In worked example 2 then, the population here have been divided into strata based on the region of the country in which they live. And what we want to do then is to have a representative response from 5,000 questionnaires. So rather than dividing our 5,000 by 4 and saying let's collect 1,250 responses from each region, we want to make it representative to the number of people that live in each area. What we need to do then is work out what the representative response is going to be, and we want to end up with 5,000 questionnaires in our total box, so we know that the total of our sample must come back to 5,000. So what we want to do then is we're going to look at the proportions, and the north then is 75,000 people out of 300,000. That's going to represent 1/4 of the population, and so therefore it's going to represent 1/4 of the survey results, so 1,250. We then need to repeat for the other regions. So for the east, the 36,500 people represent just over 12% of the population, so they need to represent 12% of the sample. You end up with 608.3, but we're told not to show decimals and to round to the nearest number. So make sure you follow the instructions given in the exam. Once you finish, you can see that it adds up to the total sample size of 5,000. In example 2 then, we think about how this could be examined. So it's going to be a narrative question if it's understanding the facts and the knowledge. And what we've got here then are 4 different statements regarding sampling, and we have to say which ones are true. If a sample then is selected using random sampling, it will be free from bias. So that's true. A A sample frame is a numbered list of all of the items in the sample. Well, actually it's not, because including all of the items in a population is not a sample. It's going to be a census if we include all of the items. So sentence number 2 is incorrect. Multi-stage sampling is a non-random sampling method. Well, that's actually not true as well, because it's a form of quasi-random sampling. At each stage in a multi-stage sample, another sample is picked at random, so it is a form of random sampling. In quota sampling, investigators are told to interview all the people they meet up to a certain quota. Well, that is true. So the correct answer here then is going to be D. When choosing the correct answer in an example like lecture example 2, we need to have a look at all of the statements, but we can also use the combination of answers. So you can see here then that in all of these cases, statement 1 is true, so we don't really need to worry particularly about that statement. And actually, once we've decided that statement 2 is incorrect, that only leaves us with D as an option. So although you shouldn't rely upon the answer to help you answer it, you can use it as a double check at the end. Obviously, in a multiple choice exam, you're not going to actually have to write a report, but you do need to be aware of the purpose and contents of reports. Generally speaking, then, a report is going to initiate some kind of decision or action, and those could be control decisions or future planning decisions. They might be routine reports such as budgets, or they might be ad hoc and non-routine such as market research or the outlines of a proposal. And the features of the report will depend then on what it's being used for, but there's likely to be some kind of information and description, some kind of analysis, and then an evaluation. And the important thing is that they're tailored to the user's needs. Often then our tables and diagrams will be included within reports, and these could be through tables, charts and graphs. And what that's going to result in then is a summary of the information being presented in a way that is visual. And the information could be summarised via the calculation of averages, time series and ratios, all of which you will encounter later on in the course. A table then is going to show the information in rows and columns, each of which should be titled, and it's going to give you 2 different variables. There are different types then of charts that we can use. These are much more visual than tables. The type of use then will depend on what it wants to show, how accurate it is, and also who is going to use the data. So we might see something like a bar chart then, which is just going to show a separate bar for each class within the population, and the height will be proportional to the amount of times which it occurred. The widths then of the bars drawn are always the same, so there's no dominance on one particular period. And you can see here then in the example that this chart is very useful at showing the increased trend in the profits year on year. A component bar chart then is a similar idea, but we're going to have different components for each year. And they'll always be stacked in the same order so that you can see the relative importance of each of the components. So what we've got here then in B are the sales of the different products. This has got twofold benefit. You can see then the increased trend in overall sales, but you can also see the magnitude by which each have increased. So product C then has stayed relatively stable, but there's been much greater proportional increases in A and B. Multiple bar charts then will have a set of bars for each class, and they'll be broken down into percentages. The third type of bar chart then is a multiple bar chart, where we have different bars next to each other representing the different products. And you'll notice that there's a clear space between each set of bars, making it easy to identify the different years. Finally then, in the bar chart section, we have a percentage bar chart. So each bar then is the same length, representing 100%, but you can see that the constituent parts are the percentages that have been calculated. So you can see here then that product A was the greatest in 2000 and X9 and 2000 and Y1. The next type that we need to look at is a pie chart. A pie chart also is based on percentages, but this shows the relative size of the components as a part of a circle. So what we have here then in the example is the destination of UK graduates, and we can see that the majority of them, 65%, are going to go on to a long-term career. And to work out the segment of the circle, we take the percentage and multiply it by 360 degrees, because there are 360 degrees in a circle. So 58 degrees will be represented by the 16% who've gone on to temporary jobs. And we'll see an example of how that could be used in a question shortly. Before that, we need to mention scatter graphs then, which are graphs used to show data where there's two sets of variables. So for example, you could plot height and shoe size onto a scatter graph. We don't have a diagram of a scatter graph here, but in chapter 12 we'll be looking at using scatter graphs as a statistical forecasting technique when we're looking at predicting total costs compared to the number of units produced. In example 3, we're going to look at one of the ways in which this could be tested. So we could see questions on presenting information in fact recall type questions, but here in example 3 is some application. So we've got 4 regional divisions and we're given information about the sales for the last quarter for those 4 areas. And what we want to do is to work out how many degrees would be represented by the South Division. So the South Division then is 120 million of sales out of total sales of 720 million. So that's just over 16%, but we need not to give it as a percentage, but to give it as a number of degrees. So we have to multiply it by 360, because there are 360 degrees in a circle. So that would be represented by 60 degrees, which is answer B. The amount of work that you need to do to prepare you for the spreadsheets area of the syllabus will depend on how familiar you are with Excel. So some people then will have been using it very widely in their workplace, but if you haven't used Excel, it's very much worth working through chapter 15 of the study text with Microsoft Excel open on a computer to make sure that you understand the theory and that you can see the formulae in action if you've not had chance to witness that. So a spreadsheet then is an electronic piece of paper divided into rows and columns, and the point at which they meet is a cell. So each cell then will have a unique location, for example B4, and you'll be able to work out that that is the 4th row down in the 2nd column. Cells then can hold lots of different types of information, including numerical information, and we can process that information to enable the spreadsheet to do lots of the basic arithmetic and calculations for us. So for example, we could use it to add VAT to our cost prices to work out the sales price for the customer. Here then we've got a list of applications for spreadsheets for management accountants, and I'm sure you can think of lots of others. So you can use them to prepare the management accounts and indeed the financial accounts. You can use them for historical cash flow as well as future forecast and budgets. You can use them for reconciliations like the bank reconciliation or the purchase ledger reconciliations, to analyse out costs and revenues, for variance analysis and comparisons with prior periods, and also for sorting, perhaps into largest to biggest, filtering perhaps customers that have spent over a certain amount, or categorising large volumes of data. A bit of terminology then. A text content of a cell is anything like words, abbreviations, descriptions, references, keywords, or a decision summary. So that could be the title, for example, the word sales or the month. The values then are the numbers, so in the example below that could be the sales value. And the formulae are what link and provide a mathematical relationship between the cells. And there are conventions that you need to know. You can find more, as I said, in the study text. But the example here is that A1 star B1, so equals A1 star B1, means that you would multiply cell A1 by cell B1. And the cell in which you type that formula is where you will get the answer. The formula bar then on Excel allows you to see what you're typing in and also to edit your formulas. When you're writing a formula in the exam, you have to type it exactly as you would see it in Excel. And that's why it's very important that you don't forget the equal sign at the beginning. In example 4 then, we're going to be required to write the formulae for some simple calculations in this spreadsheet showing the sales value for 3 different months. So in cell B5 then, which is this cell here, we have to work out the total of January to March's sales. Now we're not being asked simply to add them up ourselves and come up with 370, we have to come up with the formula. So we need to remember then to put the equal sign because we have to present it exactly as we would in Excel. So we want B2 plus B3 plus B4. As an alternative though, we could say equals the sum, open brackets, B2 colon to B4. What this means then is that anything between those 2 points will be added up. So the second option is particularly useful if we've got large amounts of information to add up. And both of those would be deemed correct in the exam. In B6 then, we have to work out the amount then of VAT that's going to be payable at a rate of 17.5% on that sum calculated in B5. So we've got equals B5, and then for multiply it's the asterisk button, and the VAT then is going to be 0.175 because we just want the actual amount of VAT. It's in B7 that we want the value of the sales to invoice. So in B7 down here for the gross sales, we can either do equals B5 plus B6, or we can have equals B5 multiplied by 1.175 because that will be the amount including the VAT. Sometimes then we might want to always use the same cell when we are doing a calculation. So for example, if we put the VAT rate in one cell, we might want to continue to use that one cell for all of our calculations. And that's known as absolute cell referencing, which we do by denoting a $ either side of the column letters. And we can copy that formula across using that cell repeatedly. And we're going to see this in example 5 now. So what we want to do then is to calculate the price in cell C5, which is including VAT. But rather than typing the VAT rate in, we're going to take the VAT rate from the destination cell C2. So we need to anchor or use absolute cell referencing for cell C2 when we're working out what we're going to type in to C5. So it'll be equals B5 multiplied by, and then we need to use a $ either side of the C to anchor that cell, to use the fact that we're always going to want to use cell C2. The next thing we need to be happy with spreadsheets is rounding. So sometimes then we might want to round our cells. And if we use equals round and then the cell reference and a comma, we can then put the number of decimal places required. So e.g. equals round C4, comma 2 will round everything in cell C4 to 2 decimal places. Also, we might need to know how to use logic statements for formulae with conditions. And that's what's known as an if statement. So what we say is, what is it that we're testing? And then we need to have a comma and the value. And we also need to have what's going to happen if it's true, and then a comma, and what the value should be if it's false. So it's much easier to see with an example. Equals if represents the if statement. If in cell A5 the number is bigger than 500, we'll say hooray, because if it's more than 500, i.e. if it's true. Then we'll have a comma. If it's less than 500, we'll ask for more sales. So basically what we're saying here then is if a sales manager comes in with sales of greater than 500, we're going to be pleased and say hooray. If it's less than 500, we're going to ask for more sales. And what we want to say to them, we're actually going to put into speech bubbles. Here then we've got a list of the symbols which you need to learn for using formulae with conditions. So less than and greater than are fairly obvious, as is equal to, but less than or equal to, we use the less than sign followed by the equal sign. So we don't actually have a specific symbol for less than or equal to, and the same is true for greater than or equal to. And also for not equal to, we use both of the greater than and less than symbols. In example 6 then, we need to use one of those if statements for conditions. So what we have to do is devise the conditional formulae, the so-called if it's true statement, to prompt the payment of a bonus. So bonuses then are paid if monthly revenues are equal to or exceed, so greater than or equal to 200,000. So we start off with equals if, because it's a conditional formula, and it's cell C4, and we want it to be greater than or equal to, so we need to use both of the symbols. 200,000, no commas in the 200,000, comma, and then in inverted commas, first response, which is bonus, and then a comma, and then no bonus, because if it's not true, so if the sales are not greater than or equal to 200,000, there won't be a bonus. One of the applications then of spreadsheets is that they're very useful for what-if analysis. So what if sales go up by a certain percentage? What if the VAT rate increases? So we can look at our forecasts, for example, the forecast cash flow, and we can change some of the assumptions. So we could change the assumption here from the cost of sales being 60% of revenue to 64% and see what the impact of that is. And there are lots of permutations using what-if analysis. In this chapter then you need to have a broad overview of lots of different things. So we looked at data, data being the term for facts, figures and information and measurements. Primary data if you collect it for a specific purpose, but if someone else collected it or for another purpose, it's known as secondary data. Where does data come from? Well, it could be internal or external information, and there are numerous different sources of information. The economic environment also has an impact on costs and revenues, and one of the things that we looked at was how businesses might be affected by a recession. The level of detail that you need on this isn't particularly great because of the nature of the multiple choice exam. Sampling then is where data is collected from part of the population only. A census then is if you survey the entire population. Random sampling then is when everyone or everything has an equal chance of being selected, and that can be done using random numbers. Quasi-random sampling can also be used as an alternative. Alternatively then you might have completely non-random sampling using either a quota or a cluster. Reports then have to be presented in an unbiased way, and one of the ways we can present information is through a table, a chart, which is more visual, and we looked at some examples of the different types of bar charts and also a pie chart. The final area of the chapter was thinking about the formulae and functions in Excel and making sure that you're confident in writing basic formulae.